Next is Ricci's theorem. According to Ricci's theorem, the covariant derivative of canonical delta and the fundamental tensors Gij and Gij are 0. So, if we take the covariant derivative of this canonical delta with respect to some k, it will be 0. Similarly, for the metric tensor Gij, its covariant derivative will be 0. And if you are considering the covariant derivative of the conjugate tensor Gij, its derivative will be 0. Using Ricci's theorem, we can arrive at some useful results. The first one is gamma mu alpha will be equal to dou by dou x alpha of log root g. So, the magnitude of the metric tensor, that is g, that is if you find the determinant value of the metric tensor G mu alpha, we can return it as g. Okay. Now, how can you determine the determinant value of a particular matrix? You can calculate it using the equation sigma nu equal to 1 to n g mu nu into delta mu nu, where delta mu nu is the cofactor of the element. That is, if you are considering the element some g11, g12, g13, g21, g22, g23, and some g31, g32, g33. So, to find the determinant value, what you have to do is you just take g11, then find the cofactor of this particular element. And cofactor means minus 1 raised to n. Sorry, minus 1 raised to I plus j, that is minus 1 raised to 2, and you just remove this particular row and column and remaining that is G22 and G23, G32 and G32. So that is what is written here. Here I have varied the index nu from 1 to n, so I am taking the determinant value row wise. You can also calculate it by column wise. Then you can vary the value of mu from 1 to n, g mu nu, delta mu nu. So here delta mu nu is the cofactor of this particular element. Now the conjugate matrix G mu nu is defined as G mu nu is the cofactor of G mu nu divided by determinant value G. So it can be written as if you represent cofactor as delta, then you can written as delta mu nu divided by G. So let it be equation number 1 and let it be equation number 2. And also it should be noted that the value of G mu nu into G mu nu, that is when you multiply the metric tensor with its conjugate tensor, what you will get is the dimension of the space, that is n. Is also an important result. Okay, so G mu nu into G mu nu will be equal to n. Okay, now what will be the value of dou G by dou G mu nu? That is from you are going to differentiate equation 1 with respect to G mu nu. Then the derivative of G mu nu with respect to G mu nu will be 1. So what you will get is delta mu nu. Here delta mu nu is remains unaffected in this particular differentiation, since it does not contain the variable G mu nu. Now you can substitute this particular value in equation number 2. So you will get G mu nu equal to 1 by G into the value of delta mu nu is dou G by dou G mu nu. Let it be equation number 4. Okay, now using Ricci's theorem, the covariant derivative of the fundamental metric tensor with respect to some alpha will be 0. Now how can you calculate this covariant derivative? First you take the ordinary derivative with respect to alpha. Then since this particular tensor is covariant, now you can put a negative sign here. Now you just write the g and gamma here. First we can take the index mu. So the index mu remains unaffected. Then you can fix and then you can use this mu and alpha. You can write here mu and alpha. Now you have to introduce a new term, let it be beta. And for the next term g gamma. Now we are taking derivative of the second index, so the first index remains unaffected. now you can write this nu and alpha here, and you can use a new index sum beta, so you will get term like this. And according to Ricci's theorem, its value is 0. Now what we are going to do is, you just multiply the equation with some G mu nu. Okay, so when you multiply, what you will get is, the first term is G mu nu alpha into G mu nu minus G beta nu G mu nu gamma beta mu alpha minus G mu beta G mu nu gamma beta nu alpha equal to 0. Now the first term is G mu nu alpha into G mu nu minus what is value of this particular expression G. Here nu is the common index, so you can write it as canonical delta mu beta into gamma beta mu alpha. Similarly, here mu is the common index, so you can write it as canonical delta nu beta into gamma beta nu alpha equal to 0. So it can be written as G mu nu comma alpha G mu nu minus you have to canonical delta mu beta equal to 1 when mu equal to beta, so you have to replace beta with mu, so you can write it as gamma mu alpha minus, here you have to substitute beta with nu, so you will get gamma nu alpha equal to 0. Now here nu is a dummy index, so you can replace it with any other index, no problem. So I am just replacing this particular index with some mu, then these two terms are same, exactly similar, so you can write it as G mu nu alpha into G mu nu equal to, when you can take these terms to right hand side, then it becomes 2 times gamma mu alpha. Okay, so this is the value of gamma mu alpha will be 1 by 2 G mu alpha means dou G mu nu by dou x alpha into, what is the value of G mu nu? Now from equation number 4, its value is 1 by G dou G by dou G mu nu, so it can be written as 1 by 2 into 1 by G and dou G by dou G mu nu into dou G mu nu by dou x alpha. So it can be written as 1 by 2 into 1 by G. When you combine these two terms, that is dou G by dou G mu nu into dou G mu nu by dou x alpha. So it can be written as dou G by dou x alpha. So what you are getting is, sorry, it is G 1 by 2 into 1 by G into dou G by dou x alpha. So we can make some more rearrangements. You can write as 1 by 2 into dou by dou x alpha of log G. Okay, suppose if you are taking the derivative of some dou by dou x of y, what will be the value? The derivative of dou by dou x of log y, derivative of log y is 1 by y, then you have to take this derivative of y with respect to x dy by dx. So in a similar way, when you calculate the dou by dou x of log g, the derivative of log g will be 1 by g then you have to take the derivative of g with respect to x alpha. So you will get the same time. You can make some more rearrangements, because you can write this equation as dou by dou x alpha of log root g, because the logarithm of root x root g will be log g raised to half. It is 1 by 2 log g. This 1 by 2 you can take out, so it can be written as dou by dou x alpha of log root g. So this equation is very important, that is gamma mu alpha equal to dou by dou x alpha of log root g. Now the divergence of a mu is defined as 1 by root g into dou by dou x mu of a mu into root g. So the divergence of a mu is defined as the covariant derivative of the contravariant vector a mu. So how can you define the covariant derivative? That is, first you take the ordinary derivative with respect to mu, then you just take plus sign here, then 2 times a and gamma. Here you are taking the covariant derivative, so you can just write these two index, that is on contravariant and non covariant index for the gamma, that is mu and mu. Now you have to add a new index, let it be alpha, so you can put alpha here also. Now its values, it is actually dou a mu by dou x mu plus a alpha into, so what is the value of gamma mu alpha? If one of the if the covariant and contravariant indices of this particular threshold symbol is equal, then its value will be the derivative with respect to the other index, that is x alpha, dou by dou x of alpha into log root g. Okay, we can write it as dou a mu by dou x mu plus a alpha into what will be the derivative of log root g. Derivative of log root g is log x is 1 by x, so it will be 1 by root g into dou by dou x alpha of root g. Okay, can be written as dou a mu by dou x mu plus here alpha is a dummy index. I can replace the letter with any other letter. Let me write it as a mu 1 by root g dou by dou x mu into root g. Okay, now I am taking 1 by root g common. Here there is no 1 by root g term, so you have to multiply it with a root g. Then you can write as dou a mu by dou x mu plus, here you have on a mu and dou by dou x mu of root g. Now you just check this particular term. Actually this is the root g into derivative of a mu, then a mu into derivative of root g, that is differentiation by parts. So you can write it as 1 by root g into dou by dou x mu of a mu root g. Okay, so this is the divergence of the tensor. So this is another useful result. Okay, thank you.